going to see the question from signals and systems given in GATE 1990 from the Laplace transform concept. Here given that the Laplace transform of the voltage across a capacitor of a value of 1 by 2 farad is VC of S equals to, this is equals to S plus 1 divided by S cube plus S square plus S plus 1, that is also equals to 1 by S square plus 1. Then the value of the current through the capacitor at t equals to 0 plus is. So here given the options, coming to the solution, here we know that given that the voltage across the capacitor, that is nothing but we know this is equals to VC of t is equals to, this is having the expression 1 by c integral IC of t dt. This is the expression for voltage across the capacitor. So from this we can write that IC of t equals to c into, this is dVCT of by dt. So the differentiation of voltage across the capacitor multiplying with C gives the current passing through the capacitor. Here given that the Laplace transform of the voltage across the capacitor is given. Now convert this expression in terms of Laplace transform. So apply Laplace transform for this, then we'll get IC of S equals to, this is C into, we know that the time differentiation property of the Laplace transform, that is equals to S into, this is VC of S. Then given that the capacitor value, here given that the capacitor C equals to 1 by 2 farad, so this becomes equals to 1 by 2 of, this is S divided by VC of S is given as 1 by S square plus 1. So finally this is equals to S divided by 2 into S square plus 1 is the value of current passing through the capacitor in terms of Laplace transforms. Now we need to find the current through the capacitor at t equals to 0 plus. So we need to find the value of this current, value of this IC of t at t equals to 0 plus. So using the time shift, using the initial value theorem, of Laplace transforms, we know that limit t tends to 0 plus IC of t is also equals to limit s tends to infinity s into IC of s. Then by substituting the value of IC of s here, this is s into, the value of IC of s is s divided by 2 into S square plus 1. So this is equals to s divided by 2 into S square plus 1. So this is equals to limit s tends to infinity S square divided by 2 of S square plus 1. So in order to substitute this s equals to infinity, take the s square as common in both numerator and denominator. So limit s tends to infinity, taking the s square as common in the denominator, this becomes 2 into S square of 1 plus 1 by S square. So S square will get cancelled here, and by substituting the s equals to infinity in this expression, this becomes 1 by infinity, that is 0. So 1 plus 0 1, so we have 1 by 2 is the answer. So the current passing through the capacitor at t equals to 0 plus, that is IC of 0 plus is equals to 1 by 2 amperes. So the option C is the here.